Let's see. It helps if I turn on the mic. Alright. We'll be going here in a second. I'm going to be sending out some tweets and stuff. Let everybody know that we're out here. Alright, 1 second. So until then, here's some info. Basically shows our resources that we'll be using. Realm of Darkness for sprites. The woodus.com is where you get all the music and sound effects, and game facts for various statistics and other things. My Xbox gamer tag is slyprid, and my Twitter handle is @slyprid. So we'll be using tonight we'll be coding in C#, and we'll be using Monogame for our API. And some of the tools that we'll be using is obviously Visual Studio. We're going to be using Tiled for our maps. All of our code that we're going to be doing tonight will be available on GitHub. Let me go grab that real quick. Let's see, where is it? But every time I do one of these, I'll be uploading it and checking into my Git repository for everybody, so you can get it there. Let's see. So to check in, I'll be using GitKraken. And then, let's see, for art stuff, I was using paint.net. So, alright, give me a second while I get my tweets out. We'll get some music started. Also, I'll be available in the live chat too, and be monitoring that. So if you guys want to chat there, you can ask me anything, and I'll try to answer it as soon as possible. Alright, so once again, to anybody that's coming in, here is various resources that we'll be using, my handle information, what repository we're going to be checking all this into. We're going to be doing this in C# with Monogame, and what tools I've used and will be using. more seconds, and then we'll get started. Alright, song transition, let's get started. Alright, so as we see here, we're going to be starting with Visual Studio, so let's create a new project. We're just going to be starting with a Windows project for Monogame. So let's go over to my repository, create a new. So if I say Dragon Warrior, it's because I, as a kid, was raised on Dragon Warrior, so I interchangeably use Dragon Quest and Dragon Warrior. So let's name this Dragon Quest and let it set up. So as the main reason I was doing this was just because I, in the past, used to do tutorials and always had a lot of fun writing up these tutorials for making games and whatnot. And the way I ended up learning the program back whenever I was a kid was taking video games and trying to recreate them on my color computer too. So I thought I would pay it forward by doing these live streams of creating games. And so back in the day, one of my favorite games was Dragon Warrior for the original Nintendo, and that was one of the original games that got me hooked to role-playing games and all that. And ever since then, those have still been one of my favorite series of games. So I thought it would be fun to try to recreate it from scratch. Everything's not going to be exactly as the original game, but we'll try to get as close as we can and maybe make some few improvements like stair mechanics and stuff like that. So we're going to start with renaming our initial class. So this class controls all of the underlying game, and this is where everything is controlled from. So basically just do a rename. I am using ReSharper. It's just an additional tool that you can get for Visual Studio that helps do various things. So in this case, I'm doing a rename. Just name it Dragon Quest Game. And what ReSharper will do is go through and rename any instance of the word Game 1 in our project. So once that's done, I like to come in here and just clean up some stuff. Since we'll be in here ourselves, we don't need all these comments for the time being. And, you know, this is for fun, so who needs comments? Alright. Extra space on the end. Save it. Let's add this next line. So I like to use regions, but it's all just preference of whether you like fields, regions, whatnot. So I typically just add some regions for the various sections of our code that we'll be using. So initialization, content, updating, and rendering. Just makes it a little bit cleaner looking whenever we can go. I just hit the wrong keys. So Control MO will collapse them down to their respective fields. Let's make these so once again I'm using naming conventions that is basically pure preference. Alright, so first things first is I went and prepped making a lot of the content for the game already. So I did stuff like created a tile set for us to use. So here is the tile set that we're going to use. It's pretty much all of the tiles. I did some modifications to some of the overlaying tiles, so they were using multiple tiles to so like stairs on brick, stairs on grass, stairs on other different tiles, so I just made these as overlays. Then I just also added in all the different characters and directions, so we can just use one tile sheet for everything. I also have one for all the various monsters, and then one for the user interface. We'll be jumping straight into doing the first screens and like gameplay instead of doing all the UI work right now. We'll get to that in later episodes. The original NES worked off of 8x8 sprites, and so all those tiles in Dragon Quest were originally 16x16 pixels. So we went and basically scaled these up to they're 32x32 pixels. So I went through and for fun basically worked on the pixel work and drew like all these by hand again. So you can see some previous streams of my prep of doing this. So these are all just the basic graphics that we'll be using, and then I used a program called Tiled to take these tile sets and actually draw them up into the various maps that we need. So as you see here, this will be starting in the throne room, and each map so far consists of 3 different layers: a ground, overlay, and NPC. The ground obviously is just all the tiles that of the respective ground. Overlay is chests, doors, stairs, stuff that the player can interact with. And then NPCs is obviously the NPCs. And right now I got roughly 4 maps done. So we have the throne room of Tantagel, the actual Tantagel proper, the basement to Tantagel, and the first town, Breckenary. I do not have the overworld map done yet, but that is in progress. So let's minimize these and get back to our project. So our project consists of a base game class, the program which runs everything, and then content. The way the content works in this is there's a content file that whenever you open up the directory, you'll see this content, and if you double click this, it will open a separate program that's part of Monogame called the pipeline tool. This is where we manage all of our content from, and it compiles all of our content into the respective binaries for our game. So let's open this back up, and what I'm going to do is add a maps directory, and then I'm going to copy the 3 image files that I showed you earlier in paint.net, the monsters tile set and the UI, and I also have 2 sprite font files. So the sprite font files are basically just XML files that define how a sprite's gonna, not sprite, a font is gonna look in the game. So whenever we compile our content, it will take whatever font name that we provide, size, and various other settings, and compile a what's it called? A sprite sheet of our font. So since Monogame can actually use fonts straight from our system, so let's go over to our maps, copy them over. So we can see we have our 4 tiled maps, and then there's this tiled set. This here defines in tiled our tile set over here. And the one nice thing about this is whenever we can actually edit this. And let's see, oh, we got an issue here, but the nice thing about this is we can go in here and add various properties to each of the tile. So this is where I'm going to go and add in information about collision detection and whatnot, and I'm also going to try to do various sprite information for our NPCs and all that. Alright, so back in our content project, since we have all of our content added here now, we can go over here and add an existing folder. So we have content, let's add in the maps, and so we have all of these, and we'll be writing our own processor for the tiled maps. So just go in here and set these to copy. So what this does is it will copy out the files to our build whenever, instead of creating the binaries for them. So let's go over here and add in our existing items now, our fonts. And so these will automatically set an importer and a processor for these. Those are actually part of the pipeline tool. So now if we come over here and hit build, we'll have build information of it's going through and creating the binary files for all of our tile sets and our sprite fonts. So once that's done, we can close this, and all of our content is now added into our game. And we'll get to showing how to use that here shortly. So the first thing I like to do is update go through and update our, let's update these variables first. What resolutions and stuff we're going to be using. So originally the Nintendo was 320 by 200. So we're going to make this a little bit more updated and update this resolution a little. Like I was saying earlier, I updated the graphics to be 32 by 32 tiles instead of 16 by 16. And so with that, we're also going to update our actual screen resolution. So let's add a title to the game. And then we just tell it to set the preferred background width, and we're going to make this 1024 by 960. And then once we have that, we tell it to apply these changes. And so now once we run this, we should get a nice 1024 by 960 screen with an error message. Oh, it's because I made a sprite batch. So it should come up with a cornflower blue screen. And there we go. And that's our initial screen. So now that we have that, we're gonna create, well, let's change this to, instead of blue, let's change it to black. And so the way this game is going to be set up is I'm breaking each region of the game into what I like to call scenes. Each scene is basically just a logical breakdown of various things of, like, you know, this is a throne room, this is Brecconary. So we have nice little chunks of areas that we can deal with and save information. So let's add a folder called scenes. And so what this will do is set up a namespacing naming convention for us whenever we add new classes. Alright, and then let's go and create an abstract class called scene. All of our scenes will inherit from this, so we can have some common things across the board. So every scene is pretty much going to use a sprite batch, and so we're going to make this easy for us. Instead of trying to pass this all around, we're just going to create an instance of, pretty much, it's what they call a singleton. So what this allows us to is, whenever this is created, we pass our game over to this instance. So wherever we're at, we can actually use whatever properties we have set. So now if we go and see that we have it was saying that we have our sprite batch isn't accessible. So we're just gonna tell it to reference our private member, and now we should have access to it. Alright, so, and we're going to do the same thing for our content manager. Which actually should be already accessible. I believe it's public already. So we'll grab so some of these practices may not be to your liking or whatnot, but we're just trying to get things working and basically show how we can make a game through various ways. You know, coding isn't perfect and there's so many ways to do things. So this is just one way. So with the content manager, we're going to need that in all of our scenes because obviously we're going to be loading content into each scene. I'm also going to add a flag for is our scene loaded and is our scene initialized. is loaded is to let us know that our scene, all the content in our scene has been loaded and can render. And then as initialize is any managers or things that we need in our scene that needs to be there before we do any updates or rendering. And then in the future, we're going to be making an input manager. So we can add that here, but let's comment that out for now, because we don't have it made yet. So rando error. Comment this section out here, and each scene is always going to have an update that takes in a game time and a draw, which is where things are rendered. And then we're also going to have a virtual method of initialize, and the default one is going to set initialize to true. So now we have our base scene. So let's first go in, and since we're going to start in throne room, let's make a throne room scene. So our throne room scene is going to inherit from our scene, so we can pick up all those properties and methods, but we need to make sure that we have our update and our draw methods in there. Let's get rid of these exceptions. So eventually we're going to also need the initialize, but right now it's just going to call the base one to set the initialize. We'll be setting that later once we get our input manager in for we're going to do our input handling there. So right now we don't have any maps or anything coded yet, so we need to come down and need to add in some initialization stuff on the updates. So what's going to happen here is update is always first called before a draw. So we're going to check to see if things are initialized. If it's not, we're going to initialize it. And then if things are not loaded, we're going to load content. So we can also add over here another virtual method called load content, because that's where all of our content's loaded, and by default we can set this to contents loaded. And then after here we can do all of our updates for our various other handlers. And then in our draw, we don't want anything to draw unless everything's initialized and loaded. So if nothing's initialized or loaded, we're going to drop out of this. So now that we have our base throne room scene, we need some way to pass this into our current game. So I like to have a class set up to where that handles all of our game state. So in here we'll set like whether chests are open, whether certain events have been handled and whatnot, and then we can use this to write to a save file later. So we'll call this game state. So right now we don't really know much of our game state, so we'll just leave this blank for a second. And then we'll jump back over to our main game. So to get our scenes to load, we're going to need to know what scene we're currently in. So we're going to have a property here called our current scene, and then we'll take that game state that we just had and create a current state, and then we'll go down to our initialize and we'll set our current state is equal to a new game state, and then current scene. Since we want to start in the throne room right now, we'll set it there. Once we start with doing UI work, we'll start our current scene in the title screen. We have to leave this base initialize here, otherwise Monogame won't know to start loading content and all that, and we'll just end up stuck here and nothing will load or render after this. So once we have that, we need to go down and let them know we need to take whatever our current scene is, make sure that it's not null, and update it. And it'd help if I actually use current scene instead of current state. And then the same will happen down here. Check to see if our current scene is not null, and render it. So as you can see here, we're clearing our graphics device, our screen, setting it to black, and then drawing our scene. So now if we come here, we should have a black scene. It comes up. But if we come over to our throne room scene and set a breakpoint, we should be hitting it. And so we should be initialized and loaded. Alright, so next we need to actually go and set up our maps and how those are going to be loaded. Since we're using tiled, we can either import in a NuGet package to handle that, or in this case we're just going to make it quick and easy and handle the XML files ourselves. So let's add in a maps namespace. Then we come over here and let's start out with we're going to start at the topmost layer. So in order to do that, let's take a look at what actually the tiled maps look like. So this here is the actual XML file for a tiled map. So as you can see, it's just a straight up XML file. So what we're going to do is use XML serialization to deserialize this, and we're just going to have a class that encapsulates all of our various attributes here and elements. And then once we have that, we can just parse all this out, which is all of our tile information, into our various layers. Alright, so first we need to start with top layer, and that is a tiled map. So let's add tiled map. Alright. So, like I said earlier, these are all just pretty much XML serialization. So, just a class with a bunch of properties in it and some attribute hooks for XML. So we know that the root of this is called map, and we need the version, orientation, render order, width, height, tile width, tile height, spell this right, the next object ID, we're going to have a tile set, which will be known as tiled tile set. We're going to have a list of layers. And then we're also going to need an update for this, because we'll be updating a map directly. And a render method for this, which will take in a sprite batch as well. So now we need to come in here and set our attributes to what's set actually in our XML file, so it knows which field to associate to what. So this is not going to handle every scenario that tiled can do, but it'll handle a good chunk of what we need to get done. And anything that we need to add on to it, we can always adjust these to what we need. Alright, so this one is an XML element instead of an attribute. And tile set. And this one also is an element called layer, but we need to let it know that it's a list. Alright, so we have that one. Now we need to let's go and add in the tile set. So this one's the same thing. There's the first graphic ID, what the source is, and then I'm going to add in some extra post-processing stuff. So we're going to have this actually grab the content manager to create our texture. We want to have a name for it, how big the tiles are, we also need to gather information on how many columns are in the tile set and how many rows, so we can determine indexes and various other information to reference our tiles. So we're going to stick all these on ignore. because they're not actually in our XML file. And then let's go set our attributes. So now we have those. Come back here to the map and we should see that it's no longer aired out. So next is a tiled layer. And now we continue on this project, our process of adding more classwork. So here we have, has a name, width and height. Is it visible? And here we'll pull in the data for the layer, which is all of the tile information. So set our constructor and make sure that it's initially set to visible, because, you know, we need to see our layer. And this will also have an update and a draw. That will also take in a sprite batch and a tile set. So let's go up here and set our attribute information. Sorry about that. I hit the button on my mouse that shifted it to the next tab. And this last one is actually an element. And that's our data. Alright, so now we have this one set up. We continue on with the errors, so we should be able to see back here. Oh, this should be tiled layer, not tile layer. So now let's go and add the tiled layer data. And the same stuff here. We have an encoding, tile data, and then we're going to break this out into an array of tile information that we'll post-process of tiled tiles. Let's go and add our attribute information again. And this one's actually just text. And this one is ignore. Alright, so look back here, should be cleared. Move on to our next one of a tiled tile. So if we come over here, this is, for right now, all this is an index to define what tile we're going to be using and whether it has a collision. Alright, so that creates our base structure, but now we need some way to load it in. So we're going to create a helper class called tiled map loader. And it's going to be a nice static class that helps us load our tile set. Or not tile set, our map. Tile map. So it's going to take in a file name and a content manager. So this is where the file name that we're going to pass in from our actual content structure here that we set earlier. So let's pull in, let's just read all text of whatever file. And so here we're going to create a extension method to help us deserialize and serialize XML. So we need to go and let's see, where is it? We'll create a utility folder, and in this utilities folder we'll just hold our XML helper, which is just a place that we're going to put in our extension methods at. So we're going to write two extension methods here, one to write an object to an XML string, this all it's going to do is take an XML serializer and take in a generic type, output XML, and we'll set up our string writer. Now there's multiple ways of doing this, but this is just one way I've done it before. I like setting up my using so I don't have to worry about closing my streams. Then we set up our XML writer to create serialize to the string writer, and then output it as a string. You know what, we can actually move this into here so we don't have an object just sitting. So now we have our serializer, and then now let's write our deserializer. So we're going to have an output of our generic class, and pull in a string reader, read into XML, deserialize it. And there we have it. So now if we come back over here, we can use that. Alright, so now we have our XML deserialized. So let's return our map and then see how this actually works. So if we go back to our throne room scene, we know that we're going to need to load this into content. So let's override load content. Set is loaded to true whenever we're done. Now we're going to need a map. So what we're going to do here is we're going to call that loader. And we're going to tell it to go look into content directory under maps. And we want it to load the throne room, TMX. Pass in our content manager. And then let's go and set a breakpoint here. And then so now when we run it, we can see what it created. So we should hit a breakpoint here. So it said we couldn't find it. So debug content map. Oh, as you can see here, we our directory is actually called maps, I believe. Yep. So we misspelled it. So quick debug, or well, quick rename. Come over here. Let's try this again. So we have a loaded map, should be. So if we come here and like debug and look at it, we should see that now we have various information, versions, width, tile heights, render orders, orientation, all our various layers, and then our encoding, which is CSV, tile data, but we don't see any tiles here because we need to process this tile data. Also, we should see under layer that there's no tile set information being loaded. Oh, here it is. So, but we don't see any texture here loaded that we need for our game. So, this is what we handle in our tile map loader. So, now that we have all this information there, we can go in and do some post-processing. So let's handle the tile set first, since in order to render anything, we need that graphic information. So let's pull in our source. And set our paths. Apparently I leveled up according to the sound. Now I'm taking a wyvern wing back to wherever. So we're going to read in all the XML text from our tile set data that we had. Because remember that tile set data for a tile is actually stored as XML as well. I didn't show this earlier, but you can see here that each tile that I defined as a collision block is set up here. And then it also tells us what actual image file we're going to be using. Alright, so once we have the XML in, we can create our tile set. And we're going to deserialize it as a tile set data. But we don't have anything for that, so we need to come back up to maps, tile set data. And so this is also once again just a container class for our information. So but we're going to be cutting it here tonight. I'll be uploading this information to the GIT repository, and since we're about at the hour mark, and we'll continue on with this next coming couple days or so. So please like and subscribe, and hopefully you learned a little bit from this, and let me know what you think in the comments below. All right, later.